Huh. Why couldn't I send a tweet? Hmm. That's concerning. Okay. All right. Okay, so I guess for prosperity, or let me show you guys what I'm working on. I haven't open sourced this yet, but it will be open sourced eventually. So here we have a project with which you could find symbols in a Swift project source code. So it uses well, let's start from the beginning. This is the package.swift. So you have a command line tool and as well as a library. So these are the two, I guess, products. Yeah. So the library is a large part of it has been done. I guess we'll just dive in a little bit. So we can just look at some tests to get a feeling of what it does. So here I have a sample project within my text folder. It's very simple. It has a sample with a bunch of public types here. One of everything, essentially, extract enum, class, yeah, things like that. And then within the same target, there's a bunch of usage of those things. And then there's another target in a different, which consumes those public things as well. And that's a fixture for the unit test. I don't know why I have this. I probably should delete it. Delete. Okay. So now let's take a look at these tests, right? This tests essentially uses the project. The project's name is Clue, by the way. and here's roughly how you use it. You call this execute thing, and then you give it a bunch of information where the index store is for the project and your criteria for references that you're looking for. And, and as a result, the project will find all the references as well as the definition of the symbol you're looking for, if it exists, right? So I guess that's pretty much it. For example, here's the A protocol symbol, and we're looking for things that conforms to the protocol. So you have to kind of filter the result a little bit by saying, oh, I'm looking for the rule of is base of. And as a result, you can expect we find in the sample file the definition at this location, line column, and then references from it. So these are the tests, and they're all running. Well, I probably have some changes that I need to undo in order to run the tests. Let's see. Yeah, let me fix that. Yeah, there you go. All the tests are passing. I'm printing out some debug information. I'm not sure whether I want to keep it, but for now it's very useful. Yeah, so the part that's not working really well is the command line interface. That's what I'm gonna work on next, because the underlying library has changed a lot. So right now, if you run the build command, build debug. Let's do this. Wait, what is it? Debug. So this should give us build debug clue. Yeah. Oh. Yeah, so as you can see, there's some failures here. I think it's due to some recent changes I made. Anyways, the underlying library has changed a lot since I made the interface. So we're essentially giving it an update. And yeah, well, let's fix this right now. Actually, let me update the on-screen information about the string. Build command line interface. Okay, that should update now. And yeah, so why did this crash like that? Position argument exclude rules from following an array of positional arguments. I see, interesting. So this is the assertion from argument parser. Essentially, we can have two positional arguments, which is fine. Actually, I don't know why they would be positional, right? They should be options, because they are optional. How about that? And let's move this one below them. Oh, I have to do make build, make debug. Oh, okay. All right, so I guess let's review what we have so far. Yeah, so I need to flush out everything a little bit more, but essentially right now you can tell Clue, the command line tool, where your library live index store is, where the index store for your project is. And then as an alternative, you can also say, I have an Xcode project, or I have a path to a Swift project manager project. So these three are alternatives. Anyways, they help the tool to locate the index store. And here you can say the rules for the symbol as a filter, and you can say the negatives of a rule. So you can say, I want all the references except the ones that are inheritance. Or you can be really flexible and dig into the exotic stuff that maybe only relates to C++, for example. So the thing I think are still missing. By the way, most of these are optional. This notation should give you that impression. Everything except the symbol is optional. I have no idea whether anything works. This is just printing out the help. And so far, I also want to add. So as an alternative to these rules, you can also say I'm not sure whether I want to do a flag or an argument for presets. So instead of manually enter these rules, there are a couple of really handy ones that I want to make it convenient to use. So that's part of the update, actually. I don't know. I don't know whether it should be an argument or a flag, because you can say flag. For example, filter result for class or protocol consumption only. And then you can say something like rule reference only. So if I build this, I'm still also re-familiarized with the framework. Rule reference only. That looks good. Filter result for the class or protocol consumption only. Protocol consumption. Well, maybe the two side by side will inheritance conformance only, right? So you can so by default, if you look for a class or a protocol, we'll find all the references, including both use site, existential types, or just an instantiation of a class, and the subclassing or slash implementation, where you reference it colon protocol, something like that. I don't know which one is better. Inheritance, I think it's clear enough. You can't get. Well, we'll see whether we can come up with better names. So these two should help clarify something. Yeah, I also want to make it very clear on what they actually do. So let's look at the unit test that actually worked for these two patterns. So for protocol confirmation, you just say rule is base of. And then for protocol reference, you say rule is all, and negative rule is base of. Yeah, so I want to add those advanced, I guess, tips. Same as, or we can say rule is for reference all exclude rule base of. Rule is base of. Okay. Okay. Looks good. Let me just check my own stream real quick. Okay, I'm live. I don't know why. All right, I don't know why on my other computer the internet suddenly became super slow. I don't know. Whatever. Okay. Yeah, so this takes care of the interface, but it's just a pretty, like, literally just the UI of it, right? Yeah, so let's actually make it do something, because right now, if I say Xcode, well, Swift PM here, so this is how you use it, by the way. Let's just find the reference. Let's look for something interesting. Yeah, let's look for all the references to the symbol reference query. How about that? Yeah, so I guess it's partially working. As you can see, we did find a bunch of stuff. Yeah, this is the part we need to work on, is the output format, but let's just pick a yeah, so include text.swift 4335, right? Include tests 4335. Yeah, so this is this reference. So as you can see, it actually works, right? It's pretty nice. Yeah, so right now I'm just trying to make the working library, connect the working library with the command line interface, essentially. So here we first parse all the options, and then let's see. Well, actually, I need to update the library a little bit too. So that's interesting as well. Yeah, let's do that. So because I added those convenience flags, I want to reflect that in the data structure, which I called the thing, yeah, reference query. Yeah, so there's empty one, that's just for convenience. But yeah, this is what I was working on before I turned on the stream. So I want to change this struct so that instead of having these two fields, it should have something like role, and then it's just a role type, and delete these, and we'll make this something like this. Yeah. Yeah, here we go. Yeah, really, like inheritance is a little bit misleading, but I just can't find a neutral word that expresses both inheritance and conformance. We could call it like a really verbose way, but I'm hoping that this will come across with the help of documentation. Will come across without too big of a deal. Yeah, so here. Yeah, role, and then specific. Yeah, so there's a specific role where user gives us wait, how do I don't know. User gives us the roles, negative roles. Wow, this is an epic failure. I don't know how to use the autocomplete here. Okay, we have the role. We have the negative role. Huh? Specific. Oh. Okay. All right, now that I update this, I should run into a bunch of compilation errors, which is fine. I need to make this preset to translate to a the index store DB type. Actually, not even that, is more like the reference query itself, right? Yeah. Yeah, so reference query. So we have the positive rule. And here we do the symbol rule from index store DB, right? And then we switch on ourself dot rule. And if it's a preset, then actually preset must be a role preset. Okay, let's call this rules. Actually, we can make this a little nicer as well. Wait, how do you do this? Case and then preset dot reference only. For reference only, what is the rule again? Reference only means we subtract everything. We subtract base of from everything. So we look for everything. And then here we have inheritance only, where we look for the base of. That sounds right. And then for the specific ones, we just get the specific role We don't care about the negative one. Specific rules. And then, yeah. Yeah, this shouldn't be an array of rules. It should be just, because it's a set, so I was confused by the syntax. It should be one rule. Okay, so this passes the exclusivity check, which is good. Let's do the negative ones. Yeah, same branch structures. Reference only, we want to find all of them and subtract base of. For inheritance only, we find the base of ones and doesn't care about anything else. And this will just flip the orders of the pattern matching. And we're done. Okay. Nice. We haven't tried to compile yet, but we'll see how far I can push this with just the help of LSP. Yeah, so here we have some actual usage of it, right? Let's just go by the visual hints. What is this? Here we're constructing a reference query. Yeah, I also uses it as a internal thing, which is a little weird, but shouldn't be too bad. Yeah, so I have internally I use it's not a big deal. So the rule here should be a specific rule where we have these rule and empty negative rule. It's not so bad. And this is the last parameter. Yeah, specific. Okay. Oh. I guess. Should I improve the ergonomics a little bit? Can I add a default here? And a default here as well? I wonder. So here I can just say something like this. Not this, right? Yeah. This. Okay. All right. Yeah, so here instead of this, I should say positive rule. Easy. Negative rule remains. Yeah, we specifically. So here's a little bit of the implementation. We find the index store. We kind of we infer a reference query from the two previous queries, which tells us where the index store is, as well as what specific definition we're looking for. So we find the definition reference as well as build up the based on it the actual query symbol to query for, and then we for each of the necessary symbols, we use the index.db's function to find all the references flatten the result into a single array, and then we filter out some of them, like the implicits and definitions. Oh, actually, and then we also filter out. Wait, what's going on here? So we take for each symbol, right? If it contains either implicit or definition, implicit definition specifically, we filter them out, and then we filter out the ones that are definitions or the ones in our negative rules. Right, and then we return the result essentially. Okay. So here we mean positive rule. Going beyond my line column limit a little bit. Okay. Here's another instance where I'm constructing this. This should be a specific, and we have rule and negative rule. For rule, we have this expression. Oops. Reference positive rule is empty. Right. The default for positive rule should be empty. I don't want to make this too confusing for myself, so I'm gonna not touch my old assumptions here. Okay. Where was I? Okay. Right. So let's see. Positive rule could also be the preset, but does it matter here? It probably doesn't matter, right? Yeah, we have the inferred rules. Okay, perfect. Or we can use the negative rule. Okay. Format the code. Anything else? Anything else? Probably something else. Actually, we have this handy query we did before. I believe I took care of everything in this file. So we need to jump to the test and see what else we need to update. OSP does not complain. All right, we'll force it. One, two, three. Ah. Oh, clue engine. 1, 2, 3. Wait, I'm confused. Inferred reference. Oh, yeah. I feel like I've fallen into a trap of some sort. Positive rule. Infer reference is a reference query, right? Yeah. So it should have something called a positive rule. Okay. Okay, what's this? We have a USR, we have rule and negative rule. Okay, this is the old initializer, right? So here we want to do the specifics. So once it's inside, it's always specific. That makes sense. Or once in the implementation. So we got the rule. Believe this is positive rule and positive rule. Negative rule remains the same. Very convenient. Okay, now we only have the... Wait, there's more. Oh. Probably the same thing here. Hello? Oh. Okay. So here we make a couple of specific rules. Specific rule, negative rule. Nice. Anything else? Looks like it's done. And of course, in our CLI, well, in the main file, we do a bunch of stuff. These are all temporary. I'm gonna change them anyways. But I believe here we can simply say .empty. This code is kind of old. There's no empty, or what, did I not make it public? Reference query, empty. That should be okay. Ah, of course. The whole thing should be empty. Uh-oh, we broke something. Okay. So this is an insertion from index.db. All right, let's figure this out. What did I change? Let's go to start from here. So before we have two explicit things here. Now they're all empty. test class all. Okay, so it's very simple. We're looking for the symbol base class. And we look for the symbol base class. Okay, so because we didn't have a rule specified in this test, we default to wait. Empty. Right, so we're essentially executing an empty reference, which is the most convenient path. So something is broken here. Let's look further. Yeah, I'm just kind of revisiting the code for myself as well, which is, I guess, good for stream. Yeah. So here's our top level function, execute, right? We get the store. We must have changed something here, right? Yeah, it must be this line. This is where the positive row becomes empty. But how was it not empty before? Let me think about this. Before this, we have a row, we have a negative row. We initialize it. There's some other changes that I did off stream. So the reference was empty, right? An empty in the before the code change means where art thou? Okay. Yeah, the row is literally nothing. And when it was nothing, what do we do here? Did we fall back to all? Include engine.swift. We need to look into build reference query. All right. So let's trace what happens with row. So in our case, USR is empty, so we're trying to guess one. We first find the query symbol. Here we don't care about the row, right? Wait, it has to be something here. This must be wrong. Let me think. We take the query's reference positive row. If it's empty, Then we use the inferred references rule. Inferred references rule for symbol works like this. Ah, yes, this is where the problem came in. I believe this was changed, right? By default. And I changed my mind midway and changed the default again. Well, let's just do Blue Engine. Yes. So this was supposed to be all, and I made it empty. Okay. Good thing we have tests. All right. Okay, so now we have a library level representation of the concept for presets. Actually, I should update the test as well, so that it's better reflect the internal changes I just made. This cascading changes. So instead of doing this convenient thing, I should make it more like reference query dot rule, and by default is empty. Yeah, it will be pretty convenient to have an empty there too. So let's do that. Do I ever have a well, actually, this is probably convenient enough. Just in case, it's not very discoverable or something. So we can do dot empty here. Should be fine. Oh, I mean, fine with this change alone, but not fine. Okay, so here I can simply say rule. And this is gonna wreck my test code. No, actually. Hello, Gilad. What am I gonna do? Okay, I was distracted. Okay. I want to construct a reference query here. I have a role. Okay, so easy. We just take the role. And everything down here should be okay until I specify a specific role. And this is where we come in and say we can do the preset dot In this case, we're testing inheritance. This is really nice. Not gonna lie. Pretty nice. Preset. Reference only. Yeah, here in the test I called it instantiation. Actually, that's not a bad thing. In instantiation only. Or I can call it instance only. Instance. Yeah, instance versus inheritance. I like the sound of that. Here again. Same thing but for protocols, right? Preset. Protocol confirmation. That means inheritance. Here we have again reference only. Okay, what did I call it? Reference only. Oh, let's make sure the test passed first. Should be okay. Great. Now. Okay. Reference only to instance only. So instance versus, what do you call it, right? So you can instantiate a protocol or existential or a class versus inherit from a class. But you don't inherit from a protocol, even though if you say that phrase, people will understand what it means, right? You don't you conform to a protocol. You don't conform to a class. So what's the word that means both? No, we'll stick to inheritance for now. Okay, so where am I? I think this is good progress, actually. Let me check it in. This is more like add raw presets. Should I make a branch for this? Raw preset. Misspelled that. Never mind that. There's a protocol, or there's a repository for this, of course. Okay, so let me update the stream too. Add raw preset. And we continue to build the command line interface here. All right. So well, great. Now this doesn't work anymore. Something about the index store DB. I am gonna guess that. Oh, for some reason my changes in this file got. Oh, it was on the other branch. Let's continue working on this branch. Okay. Working. Good. All right, so let's flush out the main.swift, right? Actually, I'll be right back. You guys can look at this screen for now. All right. Yeah, so essentially now implementing the main file. And what we need to do now is we get the command line options from argument parser. Instead of letting the parser execute some function, we will do some validation first, and then we'll translate the command line options into our internal data structure, and then give that to the execute to the engine.execute. So there are some interesting things here that needs to be worked on. Yeah. Let me think. What's the type of it must be like parsable argument with some sort of info? No. OSP hover? Yeah, I changed my LSP setup recently because of new Vim. So now my shortcuts are gone. Like I used to have like jump to definition and stuff, and hover. Let me do some hacking here. Let's use code and see what happens. Code has been pretty nice. Oh, yeah, of course. It's the struct. Let me change it to something else. Let's call it options, or yeah, options is fine. So another way to look at this is we write a function that takes an options type and translate into a clue.query. Yeah, that's a much clearer way to think about this. With also performing some side effects as well. All right, so change this as well. No biggie. Okay. Yeah, so let's make a function here, right? I don't know why I wrote that. Sorry. We take the options. And do a bunch of stuff. And then at the end, we just say main options. Okay. So this is a better organization of code. Well, yeah. So this line is all argument parser, and below it is all me. That's right now my mental model for this. My law, more like my justification for this. So we first validate the options, right? We can just write another function for that. Validate options. We'll see how well this works. First, we check either one of these should exist. Because without one, well, wait. Infer something if all of the maybe. Okay. Wait. Guess to be practical, we can also write something like this. Did I not call it query? It's not query, it's clue engine.query. Okay, so our goal here is to generate a query. For query has 3 parts. Yeah, 3 parts. We have store, USR, and reference. They are all other query objects. Store, USR, reference. Okay. So for store, there are 2 values. There's the lib index store as well as, wait, what's the other one? What did I call the other one? Location. And then for USR, there are a bunch of stuffs. Symbol module, symbol kind. Symbol module, symbol kind. Okay, for reference, USRs and role. Okay, so we're just filling the blank. Let's figure out the library. So lib path is a string. So that's one possibility. The other possibility is we call this thing called do lib path equals try default path to index store. So it does a bunch of side effects, query the system environment, which should always succeed almost, unless for some reason you don't have your any Swift toolchain installed. In that case, we can just bail with an error message saying failed to detect toolchain, Swift toolchain. Please failed searching for, please provide lib. Okay. So this branching logic should be okay. Wait, why is it complaining about? Whatever. So now we have a library. We can fill this in. Lib path. Okay, now location. Let's move this down here. call this first. We find path to lib index store. Figure out where users index store is. Okay. So if all three are empty, we just say, hey, user, what do you mean? Where is it? Otherwise, if we have a store, what do I call location anyways? Store query location. Location is, oh, okay. I can put this here. Is a store query dot location direct. Let's call it explicit store. Did I call it store? Okay. Which one do we prefer? Let's say for some silly reason user gives us both the Swift PM and the Xcode location. What is more likely? They're probably using Xcode, aren't they? So let's do Xcode. Xcode project options dot you silly user you Xcode project name. Okay. Else. Okay, now we explode Swift PM path options dot Swift PM, because we know from previous stuff that it wouldn't be nil, right? What's up with these errors, dude? Okay. Anyway, so now we have a store location. So that's filled. Location. Okay. So for symbol module and symbol kind, these are super easy because we have them directly represented, I believe, in the options. What did I call it? Rules, reference only symbol. Do I have module? Oh, I don't even have it. Perfect. Let's get one. Okay, so there's module, symbol, kind. Let's put them after. Before. I want to draw attention to draw the user's attention to the symbol, which is the only required argument. All right. So what should we say about these? Module where the symbol is defined, because these are the arguments that helps us nail down the specific definition for which we look for references later. Kind of symbol. Yeah, this is good enough for now. I think I'll need another argument or flag that's like system or not. System. Yeah, whether the symbol is system. Oh, well, add that later. Actually, let me write a to-do there. This is part of the USR query. To do var is system. Because sometimes you want to look for references from Apple's framework. Actually, a lot of times. Yeah. Okay. And, in case you have your own redefined symbols with the same name, and you want to disambiguate, this could be very helpful. Okay, so now that I have those, I can just say module options dot symbol kind. Did I say symbol kind? Or did I actually not give them the proper? Oh, yeah, okay, symbol kind. Okay. All right. Good. Now, references. We have we need to kind of guard against we have to enforce the mutual exclusivity of these two flags. Okay, so let's do that. Guard not options dot. I really wish I have. Does this help? It does not help. Fine. I'll do it the old-fashioned way. Raw reference only. Raw inheritance only. So if both of these are true, we're going to have a problem. And the problem is raw reference only and raw inheritance only are mutually exclusive. Okay, so with that out of the way, let's start a new section. This is figure out the reference query. Let's also make a reference query. Actually, these can happen after. All right, so if options raw reference only, reference query should be a preset. What? What? Ah, there's also USR. Right. I guess we need to figure out the role as well. Actually, role first. Reference query dot role. Yeah, this is what I actually was thinking of. So this is a preset of interesting. I shouldn't call it reference only, should I? It's instance only now. Reference only. Okay. Okay. Else, if options raw inheritance only, else and more above if ever make presets. Otherwise, we take whatever the user gives us. Which what did I call it? Oh, the roles and exclusive roles are explicitly specified. Okay. Specific. Oh, this is where some more work is needed. We need to translate an array of strings to a symbol role. How do we do that? And also, should we do that in this module? Yeah, because as a library user, you should use the types so that it's safer. Yeah, the string translation should happen as a part of the interface. Okay, so let's do that. Let's add a file called symbol raw extensions. Let's import index store db. Welcome back. Extension. So we want to make a initializer. Raw descriptions or something like that. Raw strings. It doesn't matter. It's internal. So here's the interesting thing. Should we guard against invalid strings for users? Probably, because we want to. The whole point of this tool / library is to be very, very precise. Very, very precise. Which means we want this to fail, right? So, so here's the interesting thing. For each symbol rule that exists, we need to map the string value to the actual value. How should we do this? I mean, I could do a version that takes one string, right? Also failable. And then this guy just say, hey, here's roles, symbol role for raw string and strings. So I want to, yeah, we'll see if there's a better way to write this. Flat cardlet. What is the thing? Do you call it union? Form union? Oh, I can merge this. Swift option set. I think it's form union. form union. Where are the references? Or is it just set? No, actually, it's probably something like insert, right? Yeah. Okay, so now we just need to map those values from here. Now we need a list of values. Where are the values? Symbol rule. So here are the list of values. We should just take all of them. For the advanced users. Yeah. Additional index store rules. The important constant is by default and fails to value blah 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 blah. Right. So all these preset values, I'll just take them all, right? I don't care. Let's get some more space here. So, oh, what happened? Okay, so let's just clean this up. Blah 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 blah. Let's take off the heads. What else? Blah blah blah. Dynamic. Okay. So we go to the beginning of the line. We select this word, and then we start saying if raw string equals this value, self equals this. Right? Oh, that one is messed up. We'll fix it. But everything else should be like pretty standard. Yeah, this one I believe is dynamic. So if the string is dynamic, should we require the right casing? No. Well, let me fix the format here. Yeah, let's get rid of the casing requirement. Lowercase. Oops. Let's try that again. Lowercase. Well, like that, right? And then we just need to lowercase all of these. Are they all lowercased? Okay. Easy. Okay. So now we can take a role and take a bunch of strings and turn them to a set of roles. We just need to further validate it. You know what? It would be nice if we tell them which individual role is wrong, or it's problematic. I mean. So let me just write it out here for now. It's kind of a repeat of older logic, but so I want to create, we want to do the initialization, but also if something goes wrong, we want to know which ones are problematic, right? So instead of using a init, I should do something like should I throw here or just nah? From strings. Well, it doesn't really make it better. Role strings. So I'm going to explicitly return a symbol role, but also as well a list of problematic strings, right? And we can get rid of this now. Return the roles. Problematic. Well, problems is probably good enough. This now is probably better. Flip it. Okay. Finally, we can go back and start writing our validation logic. So we find the rules. Oh, here we go. Positive role and positive problems. Symbol rule initialize options dot, I believe it's just roles. If we find any problem, we will simply bell telling users invalid rule value. Okay. And it's positive and then negative. And here, I think is negative. So we run the same thing again, except now we initialize for negative rules and negative problems. We complain about negative rule values. Now that we have both negative and positive, we can finally create a reference rule with specifics being rule, positive, negative rule, negative. Now we have a reference rule. We just need to combine it with the USRs. Woo! That's quite a journey. This function is real big. Real big. Let's see if it has any dependencies. In other words, can I break it up to 3 separate functions? So in this section, we figure out the lib path, right? And then in this section, we figure out the store locations. The lib path is not referenced until later. Store reference not referenced until later. Reference rule not referenced at all. So let's break it up. Let's break it up. Infer lib store, not infer, lib index store path from options and that gives us the string, right? So now I can remove this comment. Can probably also remove this and simply return these values. Okay. So when I eventually use this lib path, I should call that value lib index store path from options. Okay. Function number 2. Index store location from options. And we're getting a store query dot location. And that's this block of code. And when we use it, it's going to be index store location. Was that what I called it? Yeah. Index store location from options. Okay. Must have misspelled something. In the store. Okay. Something about this. Options store. Why does this thing is ambiguous? Shouldn't be ambiguous. It's not ambiguous. It's silly. Okay. Now then, we make the reference, the reference rule specifically. Okay. We can also consider writing tests for these, but some of them I think have side effects. Query.rule. Okay, so we'll cut another piece of code over here, delete the comments, and instead of explicit, well, we can do so-called point-free style or something. Okay. Again. Okay. Beautiful. Okay. Actually, this should work, right? Okay. And for main logic, we get the query, which is now just glue engine.query query and then glue engine execute. Oh, how about that? Okay, let's figure out what went wrong. All right. Wrong horrendous. Let's go here and fix this. Do I need this anymore? Oh, I still need this. Damn it. Oh, yeah. This won't work. $37. Oh. That's weird. Okay. So I believe everything that I throw is an explicit type that I defined. Yeah, so this is the next part I need to implement, which is we get either an error or a result from our query, right? From our engine. So now we need to pretty print either of this. Yeah, for now, I'll just simply print it. Okay, so anything else obvious? Initialize from. Okay. Line 80. Oh, yeah, we need to write another mapping, which is not a big deal. Symbol kind. Extensions where we import index.db. Extension symbol kind. Okay, what are the symbol kinds? Is it in here? Yes. It's index symbol kind. Okay, take this. Oh, there's quite a bit of backslashers over there. Okay, let's just keep it in the comments for now and set it up. So we want a initializer where we take right. Where we take a string and then for each of the cases we'll say something like, let's clean it up. Derp. Okay. We say go to the beginning, copy it. If string equals this value, then self equals dot this. And not quite. Let's do it again. We go to the beginning of the line, select this value, start typing. If string dot lowercase equals paste it, select it, convert to lowercase, Then self equals dot. Okay, let's see if that works. Beautiful. I don't know why this. Oh, I used. Dang it. So close. I don't mind. Go to the beginning, select the word. If string equal dot lowercase is this, but lowercase, self equals dot. Okay. All right, avoid the ones with backticks. I don't know, let's call it 10 repetitions. Let's go. 5 more. Let's indent. All right, so these backslash cases. Go to the beginning, select the word. They're all lowercase, right? Go to the beginning again. If string dot lowercase. Just realized this code is super inefficient. I'll fix it. Don't worry. What are the chances this works? Yeah, no chance. No chance. I did such a terrible job. Okay. I just keep writing the inefficient way until I need to fix it. Okay, better. Still need to delete the backticks. All right, let's delete the backticks. Easy. Now let's get it more efficient. Let string equals string lowercase. And then we just delete this block of inefficiency. And at the end, we return nil. Wait. This is still wrong, right? Still wrong, right? This is better. Yeah, this is better. It also made me realize that there's similar problems here. So instead of that, we should do raw string equals raw string dot lowercase, and then delete these, and then add else. Okay. Store location was never used. That's a problem. Because we went point free, I bet. Oh, we didn't return it. Oh, this could have been a initializer too, I guess. But yeah, there's side effects, so I'm not too particular about that. What else? Positive joined. What else? Options. Wait, do I not take a USR? Interesting. I should take a USR. Let me think. USR should be optional. Wait. USR and symbol should be... I mean, USR should make symbol unnecessary. Because if you give me an USR to look for, then you essentially unlock the expert mode. So I don't need to infer the USR from the symbol for you anymore. But that presents a problem because let me think what is, let's give it a USR. Let's make this optional. USR for the symbol to look for. Well, this required me to make further changes. Let's fix this one first because we were on our way to fixing it. So we need to say symbol kind. So we need to extract the symbol kind. String. What did I call it? What did I call it? Kind. Symbol kind. Okay. I also return null, which is fine. It's users. So now, if we can't create a kind from that string, then we have a problem. Invalid symbol value for symbol kind string, then we return the kind. Okay, so here we say symbol kind from options. Very good. Oh, symbol. Yeah, now we have to figure out. Why didn't I think of this? Oh, this is actually an interesting problem because right now I assume like the US are right now I assume like the USR is the next step. It's the third step. Each of these objects from this init tells a story that happens sequentially. First, we need to allocate. We need to be able to read from the index store, which is the first object. Then we need to nail down, like figure out which USR the user want to query, which is the second step. Then we find the references of that specific USR, which is the third step, third object. But now we have an interesting problem, which is the user could give us a USR, which means we need to skip the second step, right? But that just tells me like my data structure does not reflect the relationship of these steps. There's a bit of an imperfection there. Which which almost want to make me want to promote the reference query rule to a top level object. Man, this is going to be a big refactor. And then the USR query becomes an enum. USR query becomes an enum. Something like oh, this is such a big change. Oh, let's do it later. I'll just hack it for now. Dang. So USR query, the role, I mean the function is it should help us pin down one or more USRs, right? But if a user gives an USR, then the query just becomes the USR itself. So we can skip all that logic trying to locate the USRs. So it makes sense that the same object represented. And then we just take that, we have the engine just take this value and then spits out an array of USRs and then combine that with the rules for the third step. Yeah, that's better. That's better. Bro, okay. Let me hack it. Let me hack it for now. Okay. Symbol. Right. So the way we hack it is we make this optional and the symbol non-optional, right? To do this, wait, should be optional. To do this should be an enum with case being single explicit. Right, which also means the USR should actually be an array, isn't it? And it's really should be grouped with okay, so essentially we need to make these two mutually exclusive. Okay. Now we should have less compiler errors on that front. And the only one is this. We called it exclude. I believe this is the thing I actually called it. Okay, we actually built. Let's test it. Missing expected argument symbol. Interesting. So these should be options, yeah. Okay. Okay. We found them, right? We found them. Yeah, so this is the finding object, except I guess unserialized, just the debug print. But I think these are correct, so it's working. Okay, whew. That's a big chunk of stuff. What should we call this? Hook up interface. No, this is confusing. This branch name is confusing. What was the previous one? Raw with a misspelled word. Okay, so now we can go back to yeah, this big refactor needs to happen. I renamed this, that's fine. I created a mapping for index kind from string, works fine. Yeah, another mapping for symbol rule. And then just rewrite of the main logic. Yeah, all looks pretty good. Oh man, that's intense. That's a lot of. It's pretty intense. Hey, thanks for the comments, Gilad. Sorry I didn't respond. I was very focused. Yeah, USR is just an identifier. I don't know what it's a string. And for each symbol in a Swift project, it's like almost like a URL to a symbol. It's a unique identifier for a symbol with a definitive definition. I don't know what it stands for though. Like universal is something reference. Yeah. USR index store. Not for information in index store. USR, how about Clang? There we go. Unified symbol resolution. Thank you, Haskell. Yeah, it makes no sense. Yeah. Isn't it funny that the documentation you get is actually from these wrappers instead of the actual library? Well, the actual library, either the original C++ library from Clan or LVM, or the Swift wrappers. Neither of them, like the actual author's documentation actually don't. Actually. Terrible. Yeah. Okay. So I don't anticipate much problem from this. Now the question is, do I want to do the refactor? Bruh. Actually taking the idea to production is hard. How do you install Toki on Ubuntu? Toki. Oh, probably Rust, right? Cargo, I mean. Ubuntu. No instruction about Ubuntu here. Yeah, looks like cargo is the way. Yeah, I just want to occasionally look at how much code I wrote, and it's always, I don't know, it's always very less lines than I thought. Oh, we have almost 1,000 lines of code. Interesting. Man, do I want to do the refactor? Oh, I just thought of something else. If you give me a bunch of USRs, oh, it's fine. Yeah, I was thinking the relationship between USRs and rules. Okay, so, oh, I'm scared. Okay. Okay. All right. Let me do the refactor. Oh, actually, BioBreak first. BioBreak first. Boop. All right. Let's update the stream as well. Boop. What is our current task? Update library query interface. Update query interface library and say hi. Okay. That's too long. How about that? Okay. Oh, this is going to be a project-wide disruption. But USR migration, something like that. And then we take our USR query, right? We write a new one, public struct USR query, not struct enum. Oh, this is gonna be. Oh, I can already envision the pain. The pain. Okay. We have two cases. Let's move this into an extension. The first case is explicit USRs. And the second case is a query with symbol. Actually, that means I don't need this anymore. Symbol, module, and symbol kind. Okay. And the fourth value. Whoops. Fourth value being a to-do item. Okay. All right. And for our reference query, we can just delete it. Or rather, replace it with the rules. So we can promote rule to the top level. Let me think. So reference query, positive rule, negative rule. Right. Yeah, okay. Let's make a new type called reference rule. And then remove this here. And then instead of extending that, we can just extend this. So now we have a reference rule. Can be either a preset or specific. It has convenient value. Let's move that into an extension as well. And so for query, we no longer need the roles, and we in fact no longer need the query. So query is that long-lived rule. Let's move the file name as well to reference rule. And then now our project breaks. Everything will stop building. And my pain begins. Oh, actually, Swift build won't even work. Spell that. All right, where do we start? Query, blah, 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 blah. Yeah, I don't need this anymore because I can just use the query case as a constructor. That's relatively easy. All right, that's a good place to start. The Clue engine has its own data structure, and instead of saying reference, we can just say rule, and then here we can say reference rule. Whoops. Okay. Good. Reference rule as part of the result. That's another big piece, is that for everything we return or throw, we need to write a very user-friendly, command line friendly string description with colors and all that. Yeah, that's another huge task. Okay, I think the initial bunch of work is just replace the references with the rule. Reference query with rule. All right, so this is the key. Actually, this is probably the key of it, which is, okay, let's revisit, right? Actually, this may stop me from keep going. All right, so line 86, we load the index store. Easy. Oh, actually, to do this is very inefficient for multiple queries. Yeah, very inefficient. Yeah, let me add another. There should be to do. There should be a way to run multiple queries without invoking, without with being a single command line process. Yeah, probably via deserialized input file that deserializes to something like that. So 2 steps, right? One is the engine should be able to take an array of queries, and 2, the command line tool needs to be updated so that it can fit in an array of queries as opposed to the single query that we're taking in as command line arguments. Okay. I digress. Let's go back to the engine file. Yikes. Okay. Here we are. Right. This actually could simplify things. Okay. So here we actually are inferring the role and a definition. Okay, and let's go to build reference. Role, really? Oh, no. Hold on. So this thing should give us a list of USRs, a list of rules, and a rule object, and the definition, and a definition. All right, let me write some comments for myself, right? Return a list of USRs for This sentence is too long. To search for a role to search for and a definition. Wait, a single definition, right? Oh, this is weird. This is weird. It's weird because I made an assumption that each query relates to a single definition, which is not a bad thing. Yeah, so I shouldn't allow multiple USRs to be specified. All right, let's go back and fix that. So instead of a list of USRs, you can only specify one. The USR for the symbol to look for, and it's gonna be this, okay? And then here, let's see, USRs is referenced here. So instead of this, it should be. Oh, I mean, this needs to be refactored anyways. All right, so I can go back to the engine part. Actually, no, I need to start from the USR query. So here, instead of a array, user can specify just one, right? Okay, then I think we're back here again. All right. Yeah, so we can take that one USR and it could become multiple ones. All right, and a definition. So, yeah, I mean, this is good enough. So here we actually have string and then reference rule and the symbol occurrence. Okay. Let's see. Okay, this is not so bad. Let's switch on the query dot USR, right? If it's a explicit USR, then we do something. If it's a query with symbol module kind, we do something else, right? And when it's explicit USR, we kind of just do this. Yeah, we do this branch, which we already do anyways. Okay, so instead of copying this whole chunk, let me rewrite instead. I don't know. Let me check something else here. So this is called here and only here, right? Okay. So at this stage, okay. All right. It's very interesting because it's a lot simpler because of I think this is a sign that we made the right abstraction updates. Because like here we have like a whole bunch of logic, because this was what I was checking before. Because this is dealing with a list of USRs, which presumably is given from the user. But now, since we update the interface to limit the user to only give us one, we no longer need to worry about this whole piece. Instead, we can just say, hey, give me all the occurrences of this USR for the definition rule. And now I still get a list. But for any definition and a valid USR, there should be only one value. So so I should only worry about the empty case. If candidate, and also I never handled the empty case here, which is interesting. Candidates dot is empty. Or should I guard it? Guard not else throw failure dot symbol not found. Actually, let's update this. Symbol not found by USR. Okay. And then as long as we find it, we can safely assume the first one is the only one. And now we have the list of USRs, right? And then what's this about? This is creating the reference rule. And then we're like, if the user gives us explicit rule, I mean, this I can just copy. Yeah. So I can return here now. Return, and then we'll just write our 3 things to return. First thing is the USR in an array. Second thing, we can copy from here. Third thing is our first candidate. Okay, so that's one branch. Okay, so in the next branch, we have the symbol, we have the module, we have the kind. Symbol, module, kind. Oh, this is confusing as heck. So now we go to this function. This function takes the USR. Let me see, what does it consume? It takes the USR, gets a bunch of definitions, and then it filters the definition by query.module.map. By the module and the symbol kind. Easy. So we can actually just do a little bit of update here. By name. Okay, so instead of giving it a query, let's give it symbol name, which is a string. Let's give it module, which is an optional string, and the kind is a optional symbol kind, and this becomes symbol name, this becomes module, this becomes symbol kind. Everything else should be the same. Symbol name. Whoops, what did I do? Okay. So let's rename this candidates. Let's just read the code real quick. Oh, it's called index symbol count. Right. Okay. So what we do here, we use the index.db. We essentially search the entire table by a prefix string. Here's another thing, another to do. To match the string to say to custom this value. Yeah. This is more explicit. Yeah, so the idea here is like we always search for the symbol assuming it's beginning of its we always assume that the input is at least the prefix of a valid symbol. But in reality, you always find symbols, a lot of symbols that shares the same prefix, even though one of them is the the actual entire name. So in that case, we'll find like all the definitions, and when we find more than one definition, we throw an error here. Right, so in that case, you really want to tell this library or command line tool, don't just match my name assuming it's a prefix, assuming it's the whole thing. Then that eliminates the ambiguity. This is actually pretty important. Yeah. Okay. Symbol kind. I think I just named it kind. All right. Okay. All right, so similar to the previous branch, I'm going to rewrite it, but also copying a bunch of code over. So this function has been updated so that, actually, let me think about the name of this function. Find definitions among them, find matching module. I don't know if any. Find occurrence for a definition associated with the symbol name. Okay. All right. So here we already have our symbol name, symbol module, kind. So that's pretty straightforward. Just splat this whole thing. Okay, I have the definition. So now I have a symbol for the definition. And then we need to we essentially need to figure out the USRs. Oh, easy, that's very easy to think about because we still need to return this tuple, right? So we need to figure out an array, one or more USRs. We need to figure out the rules, and we need to return this definition value. Okay, good. So this is what this line does, right? This guy takes one USR I'm so confused. Hold on. What? Oh, it's overloaded. It's overloaded. Okay. This guy that takes the definition and then check is symbol kind. And then it can give us I see. Infer definition infer query from definition db definition, and then we want the list of USRs and then the rule, reference rule. Assume no other input, infer what USRs user want to query. Want a definition. Okay, so we have a definition simple. We can take the kind. Reference rule is fine. We can take the kind, and then we can return. Oh, we can return a tuple here. The first value is the USRs, and the second value is the rule, right? And reference rule is, yep, you can say specific and then blah, blah, blah. Otherwise, you can return this, which is literally just the definition's original USR, and specifically all the rules. Okay. Now that we have that, we go back to our switch statement. Where is it? Here. So we have our definition, right? We now do USRs inferred rule definition, oops, db definition. I bet this is throwing, so let's add a try here. Okay, now we have the list of USRs. We can start returning them. I don't think the USRs has anything special, so we can just return them. For the rule, we can again steal from old Daniel here. Some of these will not make sense anymore, but we can say the query's rule dot positive, I believe. If it's empty, then we can do the inferred rule dot positive. Otherwise, we use the use this. And the negative rule is query.rule.negative negative dot is empty. If it is, then we use the inferred rule dot negative. Otherwise, we use the query. Wait, this is stupid. Okay, it's fine. Would have been better if we can say if negative can be an optional, but it doesn't bother me that much. Okay. Ooh. All right, so both of these branches returns a value now, which means I can delete the rest. Oh man. What are the chances this works? I mean, assuming I can get it to compile today. Infer query from definition. Is this used at all? No longer used. Oh, I feel like at least, yeah, when I wrote these, I was very drunk. That's why the naming is a little meh. At least I have a better, clearer refresher today. Reference. Here, the queries rules positive is empty, then all. Otherwise, we use queries rules positive. Negative is the same. Query dot rule dot negative and query So this is what happens if we don't have nil, double question mark, essentially. I feel like I'm pushing a boulder uphill. 79, switch. symbol. Oh, call it definition. Yeah, so what's happening here is if you have a symbol whose type is whose definition, I mean, if you have a variable essentially, to find all the references, you actually had for every variable that exists in Swift. Swift actually generates a getter and setter. So in order to find all the references that you normally would think of, you actually have to say you have to look for three things, three definitions: the definition of the definition, the definition of the setter, and definition of the getter. The two are the latter two are like implicitly generated for you. If you don't look for the latter two, then you won't find any quote unquote reference of, yeah. Okay. Which reminded me of something. What about properties? Never. I hadn't written a test for that, so need to check that later. Boop, boop. Okay, what else? 90. $98. Oh, whoa! What's happening here? We have the USRs, we have the roles, we have a definition. Now we just take the USRs, right? We take the USRs. We find all the definition, all the references according to the role. We make sure that we filter out the implicit definitions, which are the getter and setters that got generated. And then we filter out from these results the negative roles, as well as the definition, which we'll find again in this query. Here we have a rule. We'll just do the rule here. The query, user query, blah, 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 blah. Result. Okay. Let's see what else. 129 candidates. Candidate. $137. 140. I'm returning 2 things instead of 3 things. And 142 specific. That's because of the same syntactical issues. 139. Instead of a occurrence, I should give it a symbol. Okay, new batch. Now we're back to main. Okay, so looks like we've done the engine part. I wonder if I can run the test now. No way. Of course, the test needs to be updated as well. Yep, literally everything needs to be updated. Until then we will not even compile, let alone verify everything still works. So here we go. Number 6, what do you want? Yes, very good. Hey, what is even going on here? I'm still running all this? Huh? Okay. GitHub is telling me I've been using too much continuous integration for my private repo. I should really pay for it. Okay, sorry, I just opened my string manager. Okay. Let's go to line 33. Yes. Instead of reference query dot role, we're just reference query role now. And we're checking the 2 flags, and then we are returning the presets. Everything else should be okay because we're literally just creating the role there. Line 71. We are making right. Here we need to add some additional validation logic. Options. First, we need to make this symbol guy optional, and we get to delete this to do. Symbol to look for. Let's add a little bit of more flair. Symbol to look for replaces exclusive. How should I phrase this? I want to say, like, if you have a USR here, you don't need to include module, symbol kind, and symbol. Alternative to replaces. Let me think. What would I read that can make it very clear to me? USR for the symbol. I'm not going to explain what USR is. It's for advanced users. The USR for the symbol to look for cannot be used with symbol at the same time. Symbol name of a symbol to look for cannot be used with USR at the same time. Okay. Good enough. Point is, now this guy is optional. So back here, things got a little complicated, right? So because first of all, this is no longer a reference, this is a rule. And it's a little simpler now, right? That's good. And this got a little more complex. A little more complex. And my thinking is we dedicate a function for it, right? We are doing USR query from options returns a USR query. Good. Here we simply just boop. Might have to throw, so we'll keep an eye out for that. All right, let's write this baby. So from our command line options, what can we do, right? If the options has a, well, let's invalidate it first. If the options has a this is the pain. Because the symbol is optional, we now have to manually make sure that it's not nil. So the first thing we need to guard against is this both symbol is not nil. And USR is a nil. Right? In this case, we'll say USR and symbol are mutually exclusive. Okay. Actually, I probably need to end up switching on this anyways. So let's just switch on it. Options dot USR options dot symbol. Okay. All right, much better. So let's case on Well, let's case on nil bell. Yeah, this is so much clearer. God, I'm a genius. Yeah. You must specify. Please tell us. Please provide either symbol Wait, I'm confusing myself. Hold on. Not a symbol. Either a symbol name or USR. Because symbol is an optional argument. It's a positional argument. So I can't say dash dash symbol here. All right, then we have our happy path. We got our symbol here, right? Symbol name. And then we have our another happy path, USR. User gives us a USR, very good. And this is nil. And then we have the other path that I was handling. Here we bell again. Say symbol name and USR are mutually exclusive. Mutually. Okay. Let's see. If we have a USR, then what is our query? Our query would become a explicit USR. Otherwise, we are getting a query with a symbol name a module and a kind. And then we have a function for the kind. Symbol kind from options. Huh? You gotta be kidding. This message, this two message, or I don't believe it. Give me better messages. What do you mean? Oh, is this why? What the? Huh? Options.symbol. Optional symbol is an optional string, right? Doesn't this unwraps the string? Does it not unwrap the string? What? What is going on? What the heck is going on? Something is weird here. Anyways, we've built. Everything is building. Now, what did I break? Of course, we need to update the tests. Let's do that. All right. So our test mostly is a symbol and then something, right? And then sometimes, occasionally we give it a rule, which actually already reflects where we were going anyways. Rule turns out to be a much better interface type or currency type, if you will. So this is what a user experiences, right? So you create a query for the Clue engine. The query have 3 parts. First part is the store. Second part is USR. Third part is a rule. Okay. The rule has no member empty, which is easily fixable. And I think it makes sense to have. Wait, it does have an empty. So screw that. Roll. See, the code is simplifying. That's a good sign. So this, it should be something called like a specific. Okay, what did I call it? The USR query. Oh, query. It's called a query. And I can delete these. Oh, I like this. The use side become like a lot more crisp this way. Oh, it's built. It built. And our tests are still passing. Is this it? Did we get it? Let's look for something for ourselves. Let's look for reference rule. Okay, we got a bunch of output and looks like semi-legit output. Let me just hack something together here. Instead of printing the result, we can print for each, occurrences for each occur in, and then, well, let's just do this because we're doing a bunch of side effects anyways. We can print the occur, actually, oh, perfect. I have a thing called location string. Perfect, perfect. Thank you, past Daniel. So we can just do occur.location string. Oh, wait. Okay, so does it actually occur in all these places? Reference rule, line 13. Yep, there's one. Line 17, there's one. In the engine, there's a bunch of references. Let's see. Line 14. I think it's working. It's working. Tests. 10 and 36. Line 10, there it is. And 36. Okay, everything's working. Everything's working. Nothing's broken. I'm a freaking genius. Let's fucking go. Oh. Oh my god. This is what move USR out of query. Move refactor for explicit USR. Move, what do we do? Let's summarize, right? Okay. Oh man, let's do Oh, nice. We have less lines already. Even though I feel like I've typed so much stuff. Okay. All right, let's do one last little thing. This would be a simple one. I want to do one. Three. I can do 3 or 2. Let's go with. Hold on. 1 is actually pretty interesting. Let's do 1. So, to do number 1 is we want to give user the option, not this one on my cursor. We want to give the user the option to filter out symbols that are only either only system or not system, right? So let me take a look at the definition. Apple index.db. Occurrences. I think it's in symbol, probably. Symbol. System. No? It's in occurrences. Oh, it's in location, probably. Location. System. Yeah, it's system. Doesn't say what a system is, but I can. We all know what it is, right? Is there documentation for this? Doesn't look like there's great matches for you. Blah 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 blah. Google is pretty useless for anything that's even slightly exotic. Like, it's so freaking frustrating. So this thing literally only exists in this repository. What the freak? Okay. I mean, I'm just slightly worried that I'm misunderstanding the purpose of this, but I'm pretty sure it says what it does. So if that's the case, then this is a piece of cake, because all we need to do here is update the query object, I believe. Yeah, update here, right? Let its system, and then we just is system. And then going back here, we just say and $0.location.its system equals its system. And what is its system? Its system is a ball, right? Then pop in the stack. The USR query now gains a new field. Let's make it non-optional for now, so that we can let the compiler tell us what to update. But just from the top of my head, we should update the options, right? So alongside the symbol kind, blah, 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 it should say like, I mean, this should be a symbol group. Yeah. Whether symbol is a system symbol. This should be a bool. Wait, should it be a flag? Flag feels a little more ergonomic. Okay. Then I believe in main, when we create the query, right? USR query, we need to specify its system options dot its system. Okay, easy. Anything else? What? I'm so confused. Oh, it's not in this file. Okay. Right. So now if we say is system, we should find nothing, right? Wait, is system. So before we were looking for a reference that we defined normally. Now if I say look for this name, it's a system name, we should find nothing. Symbol not found. Perfect. Perfect. It's working. Yes. Another to do. Boop, 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 boop. Okay. Let me stash the changes, go back to master. Pull the remote changes. Delete the branches I no longer need. Yes, 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 delete them all. And pump my stash. Okay. Now the nice little new patch. Support. Let's just call it add is system filter. Boop. Uh-oh. What happened? This check failed. 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 Oh, I know what happened. I ran out of quota. Lol. Let me just pay for it. I don't know why I stopped paying for GitHub. It's crazy that I did. That's lame. They made a lot of functionality free. Yeah. So it's free in quality, but not in quantity. If you like today, I ran probably, I don't know, like 100 jobs, and no, I'm out. It is very nice of them. I used to pay for GitHub, and then we made it everything free, and then I'm like, yeah, guess I don't need to pay anymore. Okay, upgrading. $4 per month. Like most free shit ever. Take my money, please. Pay yearly. Perfect. This gives me 3,000 minutes for GitHub Actions. It's fine. I normally don't need this. The only reason I'm using it is because I'm building something in private with the goal to open source it. And when I do, I believe the quota will be lifted anyways. Please confirm your billing details. United States of America, California. All right. Credit card, PayPal. Which do I like better? PayPal, please. Oh yeah, I remember. Before the, I think it's because of the acquisition from Microsoft, right? They made things free. Before that, everything was Yeah, but I also don't remember too much because I pretty much just immediately paid whenever I ran into the limits. I feel like as a programmer, it's like the least, it's like the cheapest thing you can buy. It does not make sense to not pay for it. I guess you could use like Bitbucket or whatever, but you know. Okay, I added my payment method. Now I press this green button. By clicking upgrade to GitHub Pro, you agree to terms of service and private statements. We occasionally send you account related emails. That's fine. Take my money. Is it done? Am I done? Oh, apparently I can only have 3,000 private repos or something. Oh, 3,000 minutes. I already used 2,000 minutes. That's not a good sign. Bro, I just did, like, I literally just set it up today. And I made, what, like 5 pull requests and already ran out everything. Everything, man. All right, let's see if these things run. Okay, it's running. So GitHub Pro gives you 3,000 action minutes per month. That's it. That's nothing. So let's see. Usage this month. I've used 214 minutes on Linux and 1,200 minutes on Mac OS. I mean, we can watch this thing build in real time. I mean, it shouldn't take a lot of time. Unless this is including my... Well, this might be including my open source repos, which would suck. Get usage report. Okay, I'm getting a usage report into my email. Well, let's check it out. Let's check it out. Nope, it's all for this clue project. Yep. If you wonder if macOS minutes cost more than Linux, I mean, it may be costing more in terms of taking longer, being slower, the instances. But as far as I can tell in the report, they're just counting the raw minutes. Wait, what's going on here? Huh? Oh, it's there's some errors in the test. Errors in the test. Well, this gives you incentive to run tests and stuff locally, right? The less you fail, the more minutes you have on the CI. Well, the less retry you do, the more minutes you get. You save, which sucks. I hate saving. Okay, this should pass. Also, like, CI is not that critical at this stage anyways. Yeah, it's not that crazy. Another thing that's good is I believe now I can set up the branch rules. Before, without Pro, you can't do branch rules. So for main, let's do require pull request before merging, require status check before merging, require branch to be up to date, and then search for the rules, all of it, please. Bionic build, bionic test, focal build, focal test, Mac OS build, Mac OS test. Does test also build everything? Require conversation resolution, no. Require sign commit, no. Prevent merge commits from being pushed, perfect. Enforce to admin, no. Allow force push, no. Allow deletions, no. All right. Oh, awkward. Okay. Okay. So the interesting side effect of doing that, adding branch protection rules, is now I can also have merge when ready or whatever it's called. Right? No? Oh, wait. I need to enable it. It's in general, I believe. Auto merge. I'm so used to this at work. Like, without it, I just feel so useless. Okay. Auto merge. Yay. Asynchronous. Yeah. So is it worth to run the test only in CI and building happens as part of that step? Yeah, that's what I'm wondering too. I am a little surprised that I don't know this because I have a test for the library I'm vending, and I have a command line app. When I run test, does it also build the command line app? Because technically it's not needed, right? So let's find out. I'm gonna nuke the build directory and run make test. Right, we'll see what shows up. This is done. Add new. So this is done. Okay, so the test has run. Let's take a look at what's in here, right? Okay, we got a debug repository, debug. It does have it does build the CLI, so maybe we don't need to build anymore. Interesting. So we could get rid of it. Okay, so the pull request has been merged, right? Okay, so we could take it out. So instead of doing the matrix, I can literally just say make test here. That's kind of nice. And here I still need the matrix, but I can skip one of the variables and just say test. Stop running build on PRs. Wait. Oh, yeah. This makes the renames everything. Yeah. That's fine. Let's update the branch protection rules again. No biggie. Remove all of this. Then Ubuntu. I think you need to wait for everything to run at least once. And then you can go there and toggle it or something like that. I forgot. But It's weird. Why aren't the jobs showing up? Okay. Bionic focal. No, that's wrong. It should just say Mac OS, right? Come on. Yeah, there we go. All right. Okay. There's another to-do I want to do. Multi-query in single command line. Anchors, variable. What about properties? Yes, that's the one. That's also something new that we haven't done today, which is we are going to add a new test and figure out whether our shit is working. So in the sample project of the fixture, I'm gonna make a new symbol called class with properties. Simple property. Let's call it a string, right? Oh, that just triggered another thing. How the heck do you query for initializers? Oh, wait. You can just query for the symbol of the class name. Yeah. Okay. So I'm not going to make an initializer for it for simplicity. Now, the interesting thing is, like, I assume Swift also for each property generates a getter and setter, just like any non-local variables. Even for local variables, I think they do it too. But for some reason, sometimes the index store doesn't. Sometimes index store doesn't index local variables. That's what I'm going to say. Static, simple, static property. These names are very dumb because they're used for tests, and dumb names is actually better because you can glance the test and kind of get an idea, guess what's going on. Now I'm gonna just make another random function here instead of shifting everything down. And then here I make a class with props, class with properties. And then let's print class with props dot simple property as well as class dot simple static property. Is that what I called it? Simple static property. Why does it complain about? Oh, I see what's going on here. And we have to replicate this whole thing in the separate package. But we don't need a artificial scope for that. Okay, everything should still build. Ooh, 17 failures. Oh, that's because I didn't make a debug build. What? That made no sense. It must be because the build failed, right? Yeah. Bro. Sample usage. Class with properties. Something else failed. Actually, why did I start doing this? I think I can do this. Wait, what do I do? Oh, yes. Why did I stop doing this? This is much better because it takes me to the error. And I can just do this. Next error, please. Oh. Class with properties needs a initializer. Okay. Class with props. Class with properties. I made 2 typos and copied both. Okay, so everything passed. We just built. Now let's write the test. Let's write a darn test. Super simple. Test class properties. This guy throws, and we just run a very simple query in which our symbol name is what do I call it? Simple class property. Simple property. Simple. We should call it simple class property. Wait. Sample struct. That's probably dead code. Simple class property. No roles needed. Expected definition should be in the sample project. Line 42. Line 42, column, 42? Yeah. Column 23. And the expected paths. So we have 2 usages. We printed twice, right? We printed here. Oh, hold on. We printed, come on. Here, what? Whatever. Simple class property. This is line 34, column 26. 34. And then in the simple CLI, we printed in 27 and 22. 27, 22. Okay. So this is a new test. Let's run it. No way, it just works. It just works. This is confusing as heck. Because for variables, we get getters and setters. Apparently not for class. Let's try the same test for static class test. Static class property is defined on line 42, column 23. What? Oh, I see. I was writing the test for the class property. Now I need to write the... I'm so confused, bruh. Oh, now I call static class property. Let's make it a little bit more explicit. It's repetitive, but it's clear. Static, simple static class property. Simple static class property 4223. What? Wait, how did this pass? Simple class property should be on 43 and 16. No? Uh, 34, 26. Oh, I see what's going on. My test does not check the definition location, I bet. That's lame. That's so lame. Okay. Who tests the test code? The test framework. Okay. Equal. Result dot definition dot location string must equal. Yeah, because originally I didn't have this definition thing separated out. It's just another element in the occurrences array. but I figured it's much nicer to have that information separately in case you need it. Wait, what? Expected definition dot pass. Oh, dot 0 dot 1 terrible. Expected definition dot 2. Okay, whatever. I'm over this. I'm so over this. Okay, please, please, bro. Please fail something. Oh, 19 tests with 20 failures. Oh boy. Perfect. So there's absolute path and relative path. Oh, I see. That's why. Okay, one failure. And this time it's about the occurrences. Perfect. Have failures is better than not having failures. Static. Yeah, because I haven't updated it yet. Makes sense. Okay, static 35 31. CLI 28 27. Okay. And everything passes. Okay. Interesting. So this no... Interesting. Let's see. Definition. I wanna see what definition we get here. Print result definition. Let's call it definition dot location definition rules. Okay, I want to see what is actually the rule. Okay. It's a canonical definition. That's it. Wait, what if I write to it? Class with props, simple class, hello. Yeah, I have a hard time believing that it's that simple. I mean, now we should expect more references, right? And if I don't do anything special, we shouldn't get those references. So for this one, we should have an extra reference. For this one as extra reference. Oops, what happened? Extra reference. Simple class property should have an extra reference on line 36. Line 36, column 20. And line 29, column 16. Okay, there's no way this still passes. Yeah. Oh, interesting. Simple global variable. Only one test failed. And it's a static one because I didn't update it. That's so interesting because now it has reference, read and write references. But for global variables, oh wait, I was looking at the wrong thing. Hold on. I should look at definition result, definition symbol kind. So All right, so the test case prints first, right? Simple global. So static property, okay. Simple global variable. Simple global variable. Where is class pro? Test class properties. So this thing is called an instant property. Instant property. So instant property. Okay. Yeah, interesting. Yeah, so unlike a global variable, right? For global variable, Swift generates a get and setter by default, whatever. But for instant properties, it does not. Does not do it. That's unexpected. I'm stumped. My assumptions, man. Okay. Let's add a little more sophistication to this. Now let's get a getter and setter. Getter, wait, get, right? Return simple class property. Let's call this class property custom class. We get, we get set. We have did set. We have did, oh, okay. Get set, did set. Get set cannot be provided together with a setter. That makes sense. Yeah, I wonder what did set is. I kind of can guess what custom properties getter and setter is referenced. Wait. Okay, let me fix that test first. This test is, oops, this test needs 2 more references, and they are 3725 and 3021. Okay, we're good. Nope. Class properties. Oh yes, because I added a bunch of new references right here. So I assume we need to add sample 4615 as well as probably 4715. Perfect. Done. Okay. Now the interesting part. Test class properties with getter setter throws. I'm just gonna run a failed test just to get a feeling of what we're dealing with here. Let's expect nothing. The definition, well, what do you even get here? Okay, so getter setter, we started running. We found 5 usages. I'm so perplexed. It's the same as an instant property. So is it even necessary to customize just for global variable? Am I was I too drunk to figure that out? Hold on. So variable, right? We special case for variable. Well, also, I'm dealing with this now, so thank you. What if we don't do anything? And so before we have 2 failures, right? So does this increase the number of failures? It does not. Was it all a dream? Did I over specify this? Let's see. Simple global. For simple global, it found 3 references. What if I say getter colon blah 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 blah? Getter setter. Yeah, so getter setter still works. Huh. What? This is a revelation. I'm so glad I went down this path. Because that means there's a whole set of abstraction that's obsolete, actually. Like, infer query from definition doesn't even matter. All I need is a definition. Right? A definition has a USR. The rule, we can just hard code it. We don't need to automatically, magically change it for anything. It's just all. And that's our USRs. And that's our rule. Inferred rule. Wait, look at this. If the negative row is empty, then we use a default which is also empty. If it's not empty, we use it. So this is just literally this. Okay. And then we no longer need this. I think he's This is troubling. Because I seems to be able to accomplish everything with a single USR for each definition. Because before I was anticipating that sometimes a single definition can result in multiple USRs because of getters and setters. Okay. Oh, look at this. If it's empty, let's use empty. Why didn't I say this before? I was just blindly copying it. If it's empty, let's use empty. If it's not empty, let's use it. Okay, so now these two branches can be, I feel like it can be further united, right? Because the rule is, if it's empty, let's use all, otherwise use positive, negative, everything is the same. So now all I need to do here is have a definition variable that's like a symbol occurrence. Symbol occurrence. And then in this branch, I could say definition equals candidates 0. And in this branch, we can say definition is this. And then instead of repeating this, I can have a single return statement outside at the end. The definition is definitely initialized here. Okay. Oh, let me fix the tests first. Getter setter. Sample 4516. Sample usage 3820. Okay. Sample high 32 22 3116. 3926. Okay, 0 failures. Okay. I feel like reference rule, store query. I feel like at least in the implementation level, on the implementation level, there are a couple of instances where we're looking for strings. This can be a single string, it feels like. Return AUSR. Because we have a definition, and the definition has one USR. Now we can take the single USR and collapse this, fold this thing into this, and everything should still work, right? Yeah. Huh. And even better, now this is no longer needed at all. Not needed at all, because we're returning the entire definition anyways. So here you can simply use the definitions USR. Oh. Do I even need to do anything about the rules? Hold on. So the rule uses the queries. All I need for the rule, yeah. Wait, I don't even need the rule. Huh. That's so interesting. I can also do rule equals reference rule dot specific I can do this, and this function don't even need to return a rule anymore. It just literally just find the definition now. And we're still passing all the tests. Dang. This could have been so much simpler. Why did I do this drunk? I have a bad feeling. Like, what if I had some insights while I was drunk that now I'm missing? Okay. So let's rename this function. This function should be find definition. Find definition from query.usr. Okay. Yeah, I guess the interesting thing is like how was things like did set indexed in the database. Let me add a to-do item here. What else do I want to test? I've covered a lot of things. We got function calls, global variable references, enum cases. Enum cases, inheritance, instantiation. Yeah, covered a lot of things. Okay, I'm so tired. Think I streamed for quite a while today. OBS? Hello? Okay, anyways. Yep, pretty tired. I've streamed for 5 hours. Pretty good. Pretty good. Who knows? Maybe I'll get bored again and stream tomorrow. Or maybe later today. Maybe I won't stream programming. Maybe I'll just play a game or something. Alright. Thanks very much for watching.